Hello students, welcome back to our EduWave online classes. I hope all of you are doing great and studying well. I, your ma'am Ankita, is today here just for my little buddies of class 6, 7, 8, where I will be discussing one of the most typical terms of chemistry, which is element, compound and mixture. I assure you, after this video, these three terms will be crystal clear to you and you will be able to proceed with their questions very fast. So without further delay, let's start. I hope you remember those three states of matter which you learned in your previous classes, that is solid, liquid and gas. We all know that these three states of matter are made up of particles or very tiny particles, which is called its molecules, and for the combination of their particles these three states of matter differs. If the particles are very tightly packed, they are called solid. If it is a little bit loosely packed, they are called liquid, and if they are very loosely packed, they are called gas. So we all are aware of these three states of matter. So although these three states of matter were known, but that was not enough to study all the things present in this earth in a very detail. Hence, a further division was done. All those matter were divided into two ways. Some are pure, some are impure. Okay? So all those states of matters were divided into pure and impure. So when they studied about this pure substance, they found out that this pure can be again further divided into two ways. One is element and one can be compound. So these two things are pure in nature, whereas within impure they found that it can be mixture. So this is the division. When matter was found, they figure out some matters are pure in nature, some impure. If it is pure, it can be element or it can be compound. If it is impure, it can be a mixture of certain things. So from here, these three terms arise. So this matter can be pure, it can be mixture. Now impure, it can be element, it can be compound. Now to understand this element, we need to understand that elements are substances which are made up of only one kind of atom. Like if we talk about iron, this iron is made up of only iron. If we talk about oxygen, this oxygen is made up of only oxygen. If we talk about pure gold, this pure gold will be made up of only pure gold. So this element are the substance which is made up of only one kind of atom. Okay? So it can be, some examples can be hydrogen, it can be oxygen, it can be aluminium, it can be several things. Now the point is, or the problem was, for understanding this element which is huge in number, it becomes very difficult for even scientists. So what happened? They figured it out that we need to arrange this element according to their properties to read them or to study them properly. So here comes our periodic table. You must have heard about this term, periodic table.
This is a periodic table. This is a table in which the chemical elements are arranged in order of their increasing atomic number. So what is this atomic number? Atomic number is the number of proton, which is also equals to the number of electron present in an atom of an element. So here in this periodic table, elements with similar properties are arranged in the same column, which is called a group, and elements with the same number of electron shells, these are the shells on which electron revolves around the nucleus of an atom, are arranged in the same row, which is called a period.
After understanding this periodic table, the things become even more clear to us that these elements can be further divided into three types. It can be metal, it can be non-metal, it can be metalloid. So further division of this element was done. Now this metal, all the metals or all the member of this family is having similar properties. Properties like high melting point, high boiling point, high density, usually solid in state, and there are several more. The elements which are falling into non-metal group are also having their own properties, low melting point, low boiling point. With this, it can be gaseous in nature, it can be liquid in nature, or it can be solid state. Apart from this, their structure, atomic structure is also different. If we talk about metalloid, these are something which shows the property sometimes like a metal and sometimes like a non-metal. If you think about their examples, so metal examples can be your iron, sodium, lithium, your magnesium, aluminium. It can be several things. Now if you think about all these examples, you will come up with some similar properties. Now if we talk about non-metal, non-metal can be chlorine, bromine, iodine, it can be oxygen, it can be sulfur. So all of them are also having some similarities within their structure as well as within their properties. If we talk about metalloid, silicon, boron, arsenic, antimony. So these are certain substances whose properties are yet to understand, because they sometimes behave like metal, sometimes like non-metal. Okay, so this is all about elements. So if you take metal, if you take non-metal, even if you take metalloid, they are made up of only one kind of atom, that is their own atom. Okay, I hope it is now clear to you, the types as well as the examples. Now we will be talking about compound, our next topic. Now this compound are again a type of pure mixture, because when these elements combine chemically in a fixed proportion, it forms a new substance which is called compound. Let's take an example. Among this element, if we are taking hydrogen, if we are taking oxygen, so these two are elements because they are made up of only one kind of atom. Now if we are taking them and forming a bond between this hydrogen and oxygen, we are getting H2O, which is a water, which is a compound. So what do we understand? Compound is a substance which is made up of elements combining chemically in a fixed proportion. Why fixed proportion? Now if there is a proportion of 2 there is a proportion of 2:1. Now if you take more hydrogen than this, then also the things will not work. If you take more oxygen than this proportion, then also compound of water will not form. Okay, so for one molecule of water, we need 2 portion of hydrogen and 1 portion of oxygen. Similarly, let's take another example. If we are talking about our common salt, which is NaCl. Here we can see the proportion is 1:1. Now this is a compound NaCl which is made up of sodium and chlorine. They are in a chemical bond where we need 1 portion of chlorine, 1 portion of sodium to be react with 1 portion of chlorine to find 1 molecule of this compound, that is common salt. So basically this compound is a combination of elements in a fixed proportion and within a chemical bond. Why it is pure? It is pure because 1 molecule of water, if we take the example of water only, 1 molecule of this water does not contain any other thing than its formula, which is 2 portion of hydrogen and 1 portion of oxygen. That is its fixed formula. Okay. Now this compound can be again further divided into 2 ways. Your compound can be ionic compound, it can be covalent compound. Like we have seen that in elements there are further divisions of metal, non-metal, metalloid. Similarly, if you talk about compound, that can also be ionic compound or covalent compound. So let us discuss about this type of compound in a little bit detail where you will be understand the difference. Now this difference between ionic compound and covalent compound arise in its type of bond that is involved in them. Means both are compound, but the type of bonding between the elements gives them 2 different names. If we talk about this ionic compound, here there is complete sharing, donating and accepting of electron. In order to make the bond between 2 elements, there should be some transfer of electron. Okay. So in this ionic bond, there is actual donation of electron and there is someone to actually accept that electron. How does it work? Let's see one example. We talked about just now NaCl. Now this sodium is having 1 electron in its outermost shell and this chlorine is having 7 electron in its outermost shell. Now this 1 electron will be completely donated to this chlorine atom. Now sodium will completely lose this electron and will donate it completely to chlorine. Chlorine will accept this electron completely and will utilize in its own way. So it loses electron, it accepts electron. Now you need to understand that the number of electron is always number of proton. That means the negative charge is always equals to positive charge. Now once this sodium loses one electron, that means at that point of time the proton is becoming more than the number of electron, because it is donating only one electron. No proton is being donated yet. That means this sodium is surplus with 1 plus ion, 1 plus charge. That's why it will generate a positive charge. Similarly, after accepting this electron, this chlorine will develop one excess electron in it, and that time you can say number of electron will be more than number of proton for chlorine. As electron is negative in charge, hence chlorine will develop a negative charge. I hope I can make you clear with this. So as these two elements now develop two different kind of charge, they will come together and will form a bond which is called ionic bond, and the compound which form after forming this bond will be ionic compound. So NaCl is an example of ionic compound. Similarly, in covalent compound, what happens? There is a sharing of electron. There is a sharing of electron. Now there is no exact donation or no exact acceptation. There is a sharing. Let's take one example, like if we take the example of hydrochloric, hydrogen and chlorine. Now hydrogen was having 1 electron in its outermost shell, and chlorine is having 7 electron. Now hydrogen is having only 1 electron within it, so it cannot completely donate. Then how it will stay? It don't have any other electron in it. So what it will do, but it need 1 more electron in order to become stable. Now all these things of stability you will learn in your further classes whenever you will learn about the atomic structure. Now just try to understand why they are forming this bond. Okay, now hydrogen need 1 more electron and then it can be stable. So, and chlorine also need 1 electron to become stable, but it cannot also donate anything because it is in need of electron. Just now I told you. Now hydrogen also is in need of electron, chlorine is also in need of electron. Then what to do? They cannot nobody can donate and nobody can accept here. So what they will do, hydrogen will, among this 7 electron, with 1 electron, this hydrogen will form a sharing. Among this 7 electron, out of that 7 electron, with 1 electron, hydrogen will share its 1 electron. So this 1 electron becomes common to both of them. Hydrogen is also using this electron. Chlorine is also using this electron. Now, if you try to understand, then both of them are using the 2 electron, and then both of them are becoming stable. If you take another example like water, H2O. Now, if you see, oxygen was having, if these are the electrons, 6 electrons in its outermost shell, but it needs more too. You just try to understand that all elements need 8 electrons in its outermost shell to turn stable. Now oxygen is having 6 electrons. I have tried to draw the 6 electrons here, but hydrogen need 2 electrons in order to become stable. Now this is hydrogen which was having only 1 electron. This 2 hydrogen came up which is having only 1 electron. So it need 1 more electron to become stable. It also need 1 more electron to be stable. Now this oxygen need 2 more electron to be stable. Okay, what they will do, this hydrogen and this hydrogen will come close to each other and they will say, let's make a bond like this. Now if they make a bond like this, what is the benefit? Now hydrogen is using this electron of oxygen and becoming 2, which will give it stability. Similarly, this hydrogen is also using this electron of oxygen to become stable, whereas this oxygen is using either of the hydrogen's 1 electron and which turning into A, and it is also becoming stable. So there is no actual donation but a sharing. A sharing of electron is giving them a stability. For this share, they need to be close to each other, which is creating a bond which is called covalent bond. And the compound which arise after these elements come close to each other and form a bond is called covalent compound. I will like to give you one relevant example. For example, you one day went to school without water bottle. Unfortunately, you forgot to take your bottle. And on the same day, your best friend came up accidentally with 2 water bottles. Maybe one she put for herself, another her mother put. So when she came up into the school, she found that there is 2 water bottles in her bag. Now you said, oh, you know, today I forgot to bring any water bottle. So she said that, great, I have 2 bottles. You can take one and use it as much as you can. So that point of time, you took her water bottle completely and you use it independently, and you can drink water from it as and when you want, and you quench your thirst. Now here your friend completely donated that water bottle to you and you completely accept that bottle and hence form a bond between you two. That is called ionic bond. Complete donation, complete acceptance. Now maybe on the next day your friend forgot to bring water bottle, but you don't have any extra bottle. You have your bottle only. So what do you say? Okay, don't worry, I am having my bottle. Let's drink water from the same bottle. Whenever you will be thirsty, you will drink water from it. Whenever I will be thirsty, I will drink water from it. And hence we both can quench our thirst. So what does it mean? You are sharing your water bottle. You are not totally donating your bottle. Neither she is totally accepting the bottle and using it independently. Rather, the same bottle is being used by you and your friend. So this kind of bonding between 2 elements are called covalent because there is a sharing of electron. I hope this made you very clear. Now we are at the end portion of our discussion, which is mixture. Now at the beginning of the video I told you that the main matter can be pure and it can be impure. So mixture is not a pure substance. Why it is not a pure substance? Because it is also made up of few types of elements, or it can be made up of few types of element compounds, or it can be a mixture of compound, anything. So in chemistry, mixture is something which is made up of 2 or more substances but not chemically bounded. They are physically mixed together. Let's take one example, like your water and sugar. We mix it together to form a solution. Now this solution is also a type of mixture, or you can say sand and iron filling. Okay, sugar and salt. Any any substance when mixed together, they are called mixture. But you need to understand that in either of this, there is no fixed proportion. You don't have any fixed proportion of water is to sugar to make a particular type of solution. Like if I'm making a solution where I'm dissolving 2 spoons of sugar in 100 ml of water, maybe somebody else want the water to be more sweeter and dissolving 3 spoons of this sugar into that 100 ml water. So there is no fixed proportion. Next point is what? They are not chemically mixed together. This mixing of substance will be done in a physical process. Okay? And the third point is that these mixtures can be separated out into its component by any physical ways. Like it can be distillation, it can be filtration, it can be sieving, or it can be decantation, sedimentation, decantation. Any physical process can separate them out. Now just think about this water and sugar. If we do distillation, we can easily find them out, means we can easily separate them out. Sand and iron filling, we can take one magnetic separation can be done, where all the iron filling will be attracted towards the magnet and will be left up with only sand. Sugar and salt, so there also, if we take the mixture and dissolve into water, so salt is going to dissolve faster than sugar. So then if you take that water and salt solution and do the distillation process, again we can separate out the salt from the water. So like this, that means in a mixture all the substance will be bounded not chemically but physically. So this mixture can also be of 2 types. It can be homogeneous mixture it can be heterogeneous mixture. What is this all about? This homogeneous mixture means where the substance completely dissolve within itself. Like if we take a solution means solute get dissolved in solvent. Now if solute completely dissolves in solvent and the solution itself is tasting exactly same in every of its portion, that is called homogeneous mixture, a uniform mixture you can also say. Whereas this heterogeneous mixture is something where the substance which are being mixed are not uniform in nature. Like just now we use sand and iron filling. It can be mixed in no matter how much you are mixing it, it will not be mixed uniformly. If you take one portion of this mixture, you might find that the portion of sand is more in this portion, whereas if you take another portion of this mixture, you'll find that maybe iron filling is more than sand. So here the substance are not uniformly distributed. Okay, now if you also take sand in water, here sand will never dissolve in it and hence we will not find a uniform mixture. But in homogeneous mixture we always find a uniform mixture. Like your lemonade, when you make a lemonade, what are the things you are going to use? Lemon, sugar, salt, maybe some spices like jaljeera. Like this, we dissolve everything in water. Now that glass of lemonade will taste from its will taste very similar right from its beginning till end, until and unless there is one more chance, until and unless your spices which you might be using at the last portion are deposited at down. Then you will find the taste of that spice is more at the down of the glass. That means that portion is not very homogeneous. That portion or that spice is heterogeneously mixed in the lemonade. But if you are not using that, if you are just using lemon juice, water, sugar, salt and dissolving everything well, then the whole solution is going to be homogeneous, because the substance in this mixture is uniformly distributed. Fine. So I hope you understood these three things: element, compound, mixture separately, and able to understand its difference now. So like this, we are going to come up with some more videos of your classes as well, where very interesting topics will be covered and will be elaborately explained to you. So for that, keep tuned with us and follow us, like us and share our video as much as possible. Still, if you have any doubt, you're free to comment in my comment section so that I can clear your doubt. Till then, bye bye, take care.